Okay, what I wanted to tell you is this one. Right now, we have learned 6.1 and 6.2 more clearly. And now, actually, we have finished the first 8 hours. So this one is done. This one is done. The first 8 hours is done. Actually, it took like, so because it's the primitive part, it took around 4.5, like 4.5 hours to finish this lesson. And next day, we will quickly finish this part, right? The voltage levels, frequencies, phase, and all these things. So we have already discussed that, and Manchester encoding as well as the parity. And actually, next week, my plan is to do this encoding thing, parity, and then discuss about the other some theoretical areas like modulation, demodulation, and PSTN network, ADSL, DSL. We will discuss about that as well. 6.2 and 3 will be finishing 6.3 and 4 will be finishing the next week. So don't think that you have holidays next week, because next week is not New Year. So let's see whether we can give one day, week after the next week, but I'm not sure about that. But anyway, let's continue the lesson. For next week, we have classes, right? And then in the next day after the New Year, we will be discussing about the topologies. Okay, I just want to give you something about Manchester encoding, and that's why I asked you to rejoin. Right, Manchester encoding. Manchester encoding means basically these when you have a digital signal or digital frequency. So digital, let's say digital represented or digitally represented signal like this. Okay, this is a digitally represented signal. I just want you to learn how to convert this signal to a wave format. So one method is this Manchester encoding. In Manchester encoding, what is done? Manchester encoding is one way of converting this signal to the, right? So this one way of converting this signal to the this signal format, the Manchester encoded format. So there you will consider one signal called clock signal. The other signal is the data signal. You can see the data signal, and clock signal means clock signal is used to divide the data signal into equal frequencies, right? So there are two kinds of Manchester encodings. One is IEEE Manchester encoding. So as per G.E. Thomas, there's another way of representing Manchester code, right? What is happening when you, okay, in the Manchester encoding, when you see one in data, it will be treated as a raise in edge. Here is going up, signal is going up. And when you see one, it is treated as a raise in edge. A raise in edge means going up here. When you see 0, it's going as a falling. Raising up, falling down. 1 is raising up, 0 is falling down. Again, 0 is falling down. 1 is raising up, 1 is raising up. So 1 is again raising up. So 0 is falling down, 0 is falling down. That is one method of represent the signal, and 1 is raising up. Okay, let's use the same format, that IEEE one. So actually you have to do this in timely way without using a clock. I'm doing, assuming there is a clock. So next day, please do this and come. Do this few times and come. So 1 means 1 is treated as this. 1 is raising up. This is how you represent 1. So please write down this, right? So 0 is represented like this. 0 is represented the other way, falling down. This is how 0 is represented. Okay, next day, try to use these two and represent the signal using IEEE Manchester encoding. So that's what I want to give you. That's why I ask you to stay. Right, please write down. This is a digitally represented signal, and this is, so you have to encode this into the Manchester format. and this is IEEE method. So 1 is treated as a raise in edge, raise in signal. 0 is treated as fall in down. Then when you have 1, you have to raise up. 0, fall down. Again 0, fall down. Again 1, raise up. Likewise, you have to represent next day. Try to represent this signal and count. Okay, so with that, I'm going to stop for today. Do we have any questions to ask? Do you have any question to ask before wind up? Okay, so your silence says we don't have questions. We want to finish the class. Okay, then goodbye, good night, and please join back with the 2022 class by 8 p.m. same time. Okay, then good night. Bye.
Thank you, sir.
Okay, come.
Thank you, sir.
Come, right?